Let's discuss the power series method to solve second-order differential equations at ordinary points. Hello everyone. First, a power series is an infinite series of this form here, where a sub n are the coefficients of the series, x0 is called the centre of the series, and x is a variable. From now on, we will take x0 to equal 0 because we can always treat x minus x0 as a new variable. Now, let's consider some remarks about power series. First, a power series defines a function on an interval from x0 minus r to x0 plus r, which we call I, where r is the radiance of convergence, which is given by 1 over r equals this limit here or this limit here. We also have that the power series is continuous and differentiable in the interval I. Further, the series can be differentiated or integrated term by term, and the resulting power series will have the same radiance of convergence. An important result is the identity principle, which says that the power series equals 0 for all x in the interval I if and only if all of the coefficients equal 0. Now, let's consider this differential equation. We say that x equals 0 is an ordinary point if p of x and q of x are analytic functions at x equals 0, i.e. the functions are infinitely differentiable at x equals 0, so there exists Taylor series for both p of x and q of x. If the Taylor series for p of x and q of x converge on some interval I from minus r to r, then the ODE with initial conditions has a unique power series solution which also converges for the interval I. To use the power series method, we write y of x as a power series and then differentiate to get these terms here. We then substitute these into the differential equation, writing the functions as their power series. We want to combine these power series, but to do that we may need to change the index of the sum. For example, letting n equal 2, we have this equation here. Once we combine the power series, we should have a power series on the left equals 0 on the right. We then use the identity principle to say that the coefficients of the combined power series should be 0. Since we are dealing with a second order differential equation, we expect there to be two unknown constants in our solution, so we often find that the coefficients are found using a recurrence relation based on the first two coefficients. As ever, thank you for watching.